You are watching TypeScript Masterclass, and in this video we are diving into the world of generic, a powerful feature that allows you to write dynamic and reusable code while still maintaining the type safety of TypeScript. So whether you are building data structure like stacks or queue, or working with APIs, or creating utility function, generics makes our life easy by letting us handle multiple types on that particular single piece of code. So by the end of this video, you will not only understand what generics are, but also learn how to use them in functions, classes, and as well as in interface. We will explore real world examples and break down few advanced topics into understandable chunks. And as always, you will find all the GitHub repository link in the description. So let's roll the intro and start to unlock the full potential of generics in TypeScript. So now let us start by checking a very simple example. I want to write a function that takes an array and it will return its first item. Okay, so what I will do, I will say function, then get first array element, then it will take array and it is going to be of type number array, right? And of course it is going to return a number. And here what I will do, I will say return array of 0. So what this function is basically doing, it is taking an array and returning its first element. So how to use this function? So I will create a constant of say number array, and I will say for example 1 2 3 4 and 5, and here I will say const first number array item equals to get first array element, and I will pass the number array. Simple. So if you see here, this first number array item is going to be of type number. Why? Because this get first array element takes an array and returns a number. So this is working perfectly fine. Now my requirement has changed, and now I want to write a function that takes a string array and return its first element. So here I will say const string array equals to, and I will say for example apple, and let me add one more fruit, banana, and say guava. So I have a string array and I want to say const first string array item equals to, now what I have to do, see this function is taking an array of type number, but now I want to pass an array of type string. So if I pass this string to this function, it will obviously throw error, right? Because you cannot pass array of string to array of numbers. So what choice I have? So one choice that I have is to copy this function. Okay, then what I will say, get first array element, and I want to name it as string, and then I will change it to string array, and of course this will return a string, and here I will take this function and use this instead. Great. So this will work. Now again, say for example there is a array of objects. Now again, if I have to get the first item from the array of objects, what I will do, I will write another function, right? I want to pass an array of boolean, say for example. So I want to write a method that get me the first array element of a boolean. So again I will write a method for that. So if you see, this is not the ideal way, right? You cannot write the same function with the same logic for different data type. This is exactly where generics comes into picture. So here I'll remove this function, right? And what I will do here, I will say this function is going to take a generic type. That means at runtime, this generic will give me the actual array type that I want to pass. Okay, so here I want to pass number, then later on I might want to pass string, right? At some point I might want to pass boolean, right? So this is where generic comes in, and it will take a type. Okay, so I will say array type. Okay, and this array type I will use as this array type. Okay, and this array type will be returned from here. Now what does this mean? So when calling this function expects a data type to be passed. So if I say here as number, okay, this number will come as array type, and this array type will be used here as the argument. That means when I say number, it will become number, and this array will become type a number of array, and it will return a number. Okay, now I will use this function again, and instead of number I can say string. Now this string will come as this array type. Okay, and this array will become string type, and it will return a string. So now this same function is working for number as well as working for string. Now can I make it work for boolean? So what I will say, const first boolean array item equals to get first array item, and I will say boolean, and I will pass a boolean array, so true or false. And most importantly, if you see here, what will be the return type? So if you see here, first number array item, return type is number. If you see first string array item, the return type is string. And first boolean array item, what is the return type? The return type is boolean. And how this is possible? Because I am saying boolean, string and number as this generic parameter, and this generic parameter is what is being written. So if I say a number, it is returning a number. If I say string, it is returning a string. If I say boolean, this will return a boolean. Okay, so this is the whole idea of generics. You pass a type on which you want your function to be typed on. So if you want your function to be typed as a number array, you pass number. If you want it to be a string array, you can pass it as string. And the general convention is to use a single letter type. So say for example, I can say T. Okay, and here I will replace this with T, and here also I can replace this with T. This is just a convention. Okay, so if you want, you can name anything A, B, C. If you want, you can write your own name. Okay, so just how I said array type, right? But this is just a convention, T, U, V, X, like that. Okay, so the same function, we can use it with number, we can use it with string, we can use it with boolean, we can use it with any data type. And any data type means there are some ways in which we can do constraints. That means we should be able to use certain type of data, but we'll see that later in the video. For now, we can pass any data type and make it work. Okay, so we'll take one more example. So here I want to create a function that creates a tuple for me. So a TypeScript tuple. So this will take 2 arguments. So let me write the function first. So function create tuple, and it will take the first item. Say for example, it is of type string, and second item, and say for example, it is of type number. And what this will return? This will return string and number tuple. And what this will do? Simply return first and second. Okay, now what I want to do, I will say const string number tuple equals to create tuple. Okay, and first parameter what I have to send, I will say apple, and the number I'll say 4. Okay, so this will create a tuple. And what will be the type of this one? String comma number. Great. Now what I want to do, I want to create another tuple, string boolean tuple equals to create tuple, and I want to say for example banana, and I want to say false. So this is the tuple that I want to create, but this won't allow me, right? Because the first argument has to be a string, the second argument has to be a number. So first argument I am passing it as string, but when I try to pass the second argument as boolean, it is immediately throwing error, right? So here also we are going to use generic. So generics has come to rescue. So what we will say, see here there was only one argument, so we used only one generic type. Here there are 2 different arguments, one is a string type and one is a number type. So here I will take 2 generic parameters, T and U. Of course name you can change, right? So the first one, instead of string I will say T, and the second one, instead of number I will say U. And what this is going to return? This is going to return T and U instead of string and number. So if you see here, now the error is gone. Why it is gone? Because it has now inferred that the first parameter of type T is a string and the second type is number and boolean here. So here I am not explicitly saying, but I can pass the explicit generic parameter as string and number here, and here I can say string and boolean, right? So if you see the type here, it is still string and number, but if you see the type here, it is going to be string and boolean, right? So now for example, I want to create a string tuple. Okay, here what I will say, create tuple of type string comma string, and here what value I have to pass? I will say guava, and can I say 4? So if you see, it is giving squiggly. Why it is giving squiggly? because this parameter clearly says this argument has to be of type string. So this parameter I can say for example available. So it has to be of type string. It cannot be a boolean, it cannot be a number, it cannot be of any type, only it can be of type string, because here I am saying string. Okay, so we can have one parameter like here, one generic argument, we can have two generic arguments, we can have any number of generic arguments as much as we need. And what this is helping us in achieving, in the same function we can change the data type at runtime. That is the important here. So this is the usage of generic in a function. Now let us check how we can use generic in a class. So let us write the good old stack class. So I will say class stack, okay, and here I want to instantiate an array. So I will say private items, and this is going to be of type number array, and I'm initializing it with an empty array. Then I want to have a push. So what this push is going to take, this push is going to take a value item of type number, and here what I can say, this dot items dot push, and I will pass the item. Then I'll write one more method, say pop. Okay, and what this will return, this will return the number that it has just popped. So what this will return, this will return number. Okay, and it will say return this dot items dot pop. And if you see, we are getting a squiggly here. Why we are getting squiggly? Because this pop might return a number, or it might return undefined if the array is empty itself. So we cannot pop anything out of this one. So here I will say number or undefined. So this will fix the error. Now here what I can say, I can say const a number stack equals to new stack. Then what I can say, I can say number stack dot push, say for example 5. Okay, and I will say number stack dot say push, and I will say push 10. Then number stack dot pop, and let me assign it to a variable. Okay, so const let me say number pop equals to number stack and pop, and it is giving spelling error, so let us say POPPED, popped. Okay, anyway, spelling doesn't matter, but anyways, let us fix it. Then what if, so this is working with number, right? So can I say const string stack equals to new stack, and here what I want to do, I want to push string. So I will say string stack, okay, dot push, and say for example apple. Is this going to work? No, right? Why? Because this stack, its item type is of type number, it is expecting an item of type number, and it is popping a type of number. So here the number type is hard coded. So when I create number stack, it works, but when I'm creating string stack, it will not work, right? So how to fix this one? Of course, generics will come into rescue. So I will say T. So what is this T? T is going to be the items type. It could be number, it could be string, it could be boolean, it could be a object type, right? Now here T, instead of number, I will say this is of T array. It could be number array, it could be string array, whatever I pass when I'm creating the, when I'm instantiating the stack class. So, and since this is T, this is going to accept an item of type T, and it is going to return a item of type T or undefined. So now this stack is not hard coded as a number stack, but a stack of type T, which at runtime can be anything. So if you see here, I can pass number. So of course all the number will work, and at runtime if I pass string, now if you see I'm able to push string. And if you see this pop type, what is the type of this pop? Number and undefined. Now here if I say string popped equals to string stack dot pop, if you see what is the return type of this one, the return type is string or undefined. If you see here, this is number or undefined. Now how this is working? Because of this T or undefined, and this T is whatever we are passing here, and what we are passing either string or number. So that's how with the same stack class I can use it as a string, as a number, maybe I can use it as a boolean, maybe I can use it of a particular class type. Now here we are passing this number or this string, right? Now say for example in this string I am passing this as a string type. Now even if I don't pass this one, is this going to work? Yes. So this is going to work, and it is taking this apple as a string type. But what is the problem here? So if you see this return type, it says unknown. it doesn't know what it is going to return. Okay, so here we will say string. Now it knows what it is going to return, so it returns string slash undefined. So even if you remove, it will not throw any error here, but as such you will lose all the TypeScript type safety. Okay, what do I mean by that? So say for example, this is a string, this is going to be a string. So here I can say string popped dot length. Now why I am getting length as the property? Because TypeScript knows that this string popped is of type string, right? Now if I omit this one string, okay, as such you will not get any error. Okay, but if you see this string popped is of type unknown, so if I say string pop, if I say string pop, and if I say dot, I am not getting any suggestion. Why? Because it doesn't know what type this string popped is. Okay, so you always explicitly specify that what type this generic argument is going to take, then only we will be able to leverage the full power of TypeScript. Now if you see, I am getting suggestion which is specific to string. Okay, now here if you see this number pop, so if I do number pop and dot, here what I am getting, I am getting the TypeScript context specific to number, right? So that's how we can leverage the power of TypeScript with generics. Just because I am using generics, I am not losing the type safety, as long as I am writing the generics in a proper way and I am explicitly passing the generic type when instantiating the object, or I am using it in the function. So we have seen generics in function and in class. Where else we can use it? We can use it in interface. So let us check one example for interface. So what example we are going to cover? So if you see ORMs like type ORM, micro ORM, they expose a repository, and that repository we can pass a particular entity type, and when we pass that particular entity type, we get, say for example, find one that is specific to that particular entity. So let us try to create a similar ORM type of repository pattern. Of course, we are not going to write the whole repository, it is just the class and the interface. Okay, so here what I want to do, I want to create an interface. Okay, and I am going to add two methods. One is to add an item, and of what type? Okay, so say for example, here I want to define a user interface. Okay, so I want, or it could be a class also, right? So I will say interface user, and for our example we'll just work with interface. Okay, so I'll say id of type string. Okay, then name of type string, and say for example email of type string. Okay, so this is the user entity. Okay, and here I am creating an interface, okay, that has a add method that takes a user type. Okay, and what it is going to return? It is going to return void, and here I have to give a name, so that's why it is throwing all this quickly. So I'll say repository. Okay, then so it has a add method, it has say get all method, so it won't take any argument, but what this is going to return? This is going to return user array. Okay, and say for example, let me add a delete. Okay, and what this is going to take? This is going to take an id of type what? Id of type string, and what this will return? Either it can return a void, okay, or it can return the user that it deleted. Okay, so in our example, let us take the user that it is deleting. Okay, then what I want to do, I want to create a class. Okay, and I want to call it as ORM repository that implement the repository interface. Okay, now if you see, it is giving squiggly. Why it is giving squiggly? Because we have not implemented all the methods that are given in the repository interface. So what I will do, I'll say quick fix and implement interface repository. So it has just did the implementation, and it is throwing a error, method not implemented. And anyways, for our purpose, I'm not going to implement this method, because implementing this method is not as important as understanding the in and around of what is happening, right? So for our purpose, at least I'm not implementing it, but we'll see. Now what has happened here, if I create a, say for example, const user repository, and I will say new ORM repository. Okay, then I can say user repository dot, say for example, get all. Okay, so if you see this one, I will say const all users. Okay, so what will be the type of all users? Going to be a type of user array. Okay, now this ORM repository now can only work with this user type. What if I have another type, say for example product. Okay, I have a product type. Okay, this has, say for example, a product ID of type string. Okay, and say for example product name of type string, and say for example I have product description. Okay, and this is also going to be of type string. Now what I want to do, I want to use this ORM repository with this product interface as well. So for this, what I have to do, I have to write another repository that takes, instead of user, product. Okay, then I have to write another ORM repository that implements the product repository, and that is going to be inefficient, right? Because here if you see in our example, we have two products but two interface, but in real world we might have multiple interfaces, right? So now let us convert this to generic. How? So instead of this user, it is going to take the argument here in the generic as a generic argument, and here instead of user, I will say it will take a item of type T. It will return an item of T array, and when deleting, it is going to return a type T. Great. So now this is a generic repository. Now it is not bound to only user, right? So here if you see, it is giving squiggly. Why it is giving squiggly? Because this repository expects a argument of type T. So I'll say T. Then what this ORM repository item it is going to take? Is it going to take user? No, right? It is going to take type T, and it is going to return T of array, and here also it is going to return T. Now if you see, we are getting squiggly because it doesn't know what is T. So who will define what is T here? So it implements repository T, and this ORM repository will take this T as the argument or its generic argument, right? So here this T, whatever I am passing, this T will be part of this repository, and this repository is being implemented here. So since this is of type T, it is going to take an argument of type T. Get all will return an array of type T array, and delete will return this of type T. Now here if you see this generic argument, what it is taking, it is not taking anything. So let me send user. So if you see here, now this all user is going to be of type user array, but now I will say const product repository equals new ORM repository, and I will pass this generic argument as product. Okay, now what has happened here, this ORM repository is taking product, so this T is now product, or it can be user. So this T is being represented here in the repository as T. So now it can be either user or product, or can be anything, right? Any other interface or any other class, right? And this repository T is defining what this add is going to take, what this add is going to take, what this get all is going to return, and what the delete is going to. So if you see here, say for example const deleted product, okay, equals to product repository dot delete. So if you see, and it is giving squiggly. Why? Because it expects one argument. So let me pass 4, okay, some parameter. Okay, as such this parameter doesn't matter, but what I am more concerned about is its delete return type. So if you see here, what it is returning, it is returning product. Okay, here get all, what it returned, user. Why? Because I am passing the generic argument as user, right? Here I am passing the generic argument as product. So whatever I am passing here, this repository is implementing that particular data type. Here I am saying T. So user has become, so here T has become user, right? T has become array of user. Return type is T, that means user. So if you see here how useful this generic argument has become. So whatever type I will pass, it will return me that type, right? And it comes with what? Type safety. So if you see all users is of type users. So I can say all users, say for example fine, and I will say user. And here if you see what I am getting, email, ID and name. From where this is coming? This is coming from this user ID, name and email. because it clearly understands what is this user type. If I do not pass this user argument, okay, and if I try to do the same thing, here user, if I say dot, I'm not getting any suggestion. Why? Because it doesn't know what is the user type. But if I pass this generic argument as user, right, now it knows what is the user type, and I'll get suggestion, email, ID and name, right? So see how powerful this framework has become and how useful this generic is now. So I can say email, right? So with this help of this generic parameter, we can manipulate the same function to do multiple things, to do multiple returns, right? And based on the type, we can change the logic by using type guards. So if you see how powerful this framework is becoming, and just imagine the massive scale in which we can write helper function. So this is just a basic example, and next we will check different types of constraint. Now if you see, I am able to pass user, I am able to pass product, and if you see here, I am able to pass string, I am able to pass number, whatever I want I can pass, right? But there are certain scenarios in which we want to restrict what we want to pass as the generic arg. That's what is called as generic constant, right? So we'll check the generic constant next. Now let us start discussing constraints. So what are constraints? So this generic type, it can be anything as of now. So say for example, this get first array element. So here I am saying number, here I am saying string. Also I can say boolean. That means I can pass anything. Right? Now what I want is, I don't want to this t to be anything, but it should only be of type number or string. I don't want it to be of type boolean or to be of type a set or to be a type of any other map or any other object. I want it to be only number and string. So how can I do that one? So I can say t extends then number or string. See, as soon as I do this one, I am getting squiggly here in the boolean. And what problem it is saying? It is saying type boolean does not satisfy the constraint string or number. So what I have done, I have constrained this type t to be either of type number or string. It cannot be boolean or it cannot be anything else. So this is the first example of doing a data type constraint. So what I will do, I will remove all of this. We will start learning this constant from scratch. So this is the first example. So here boolean you cannot use. Why? Because I'm constraining it to number or string. Say for example, if I say boolean also, so this will start working. Say for example, I remove string, so this won't work. So this is the very basic example of doing a constraint. So I will keep this as string and I will keep this as comment. So this is the basic example. So here what I am doing, I am restricting it to a particular type. Now I want to write a function that says greet. So it will say hello user and it takes a t. And here there is a person object, it is of type t, and here I want to return, say for example, hello. Now here I want to say hello and say result 1 equals to greet, and it is going to take a person and say for example id 1 and say for example name, let me say Alice. So this is what this is taking. So this greet function is taking id and name as person of type t. So here in the generic, what I can say, this generic is taking an object which is of id of type number and name of type string. Great. So if I run this one, I will get a string return type, of course, right? Now say for example const hello result 2 equals to greet, and here id of course of type number and say for example email of type string. Then here I will call this as say id of type 2 and email. So let us say for example bob@test.com. So this is what I am passing, and this is also going to return the string. Now what I want is, see, if you see here id is common but name and email, one has name and one has email. Now instead of saying hello, I want to say hello and username. So I'll say person dot what? That is the question. Here I am not getting name or email. And why I am not getting? Because this type T doesn't know what it is going to be of type. Is it going to be of type boolean? Is it going to be of type set, or is it going to be of type object? But if it is of type object, is it guaranteed that it is going to be a property name? So say for example name, it might have a name, it might not have a name. So if you see first example, we have a name property, but if you see the second example, it doesn't have a name, it has an email property. But we are not getting any error here. Where we are exactly getting the error? Here in the function, because it doesn't know whether the person which is of type T has a property name. It might exist, it might not exist, we don't know. So we have to tell TypeScript that this T must have a property name for this function to work, because I am returning a string that is going to use this name property from person, but TypeScript as of now doesn't know. So how can I make it aware? So I can say extends an object which has a property of name string. So if you now see, this error is gone. Why? Because this T extends an object that must contain a name. So now for sure this person has a property name. If I say dot, you will see this suggestion. So I can say name. But now where it started throwing error? It is throwing error on hello result 2. Why? Because this doesn't satisfy the generic constraint on T. Why? This doesn't have name, instead it has email. So this type of ID and email we cannot use on greet, because this doesn't satisfy the constraint that we have added on that greet method. What constraint? That it must have name. See, it can have other properties, like it has ID, it can have, say for example, nickname which is of type string, and here also we have to pass a nickname, say for example Alice, but it must contain name. If it doesn't contain name, it will throw error. It must contain name along with other properties. That is acceptable, but it must contain name. That's what this extend means. Now for sure I can use person.name, because always there is a guarantee that it will have name, otherwise it will throw compilation error itself, right? So if you see here, what it is saying, ID and email doesn't satisfy the constraint name, so name is missing. So as long as it has name, it is happy. If it doesn't have a name, it will throw compilation error. So that's the power of generics with constraints. Now I can manipulate this greet to must contain a name property, otherwise I will not accept it. So this is example of another generic constant that uses object. Now can I write a generic function that accepts only function? So let us check that constant. Okay, so here what I am saying, I will write a function, okay, which is call function and return result. This is going to take a function of type, I don't know, we will write what is the type, but this has to be a function, so that what I can say, return fn, and I'll call the function here. And if you see, I'm missing, and if you see the function name is not correct, so I'll say function. So I'm calling this function here. I'll pass a generic type T, and here I'll say this is the T. Now what is the guarantee that this T is a function? So here I can say const result1 equals to call function by result, and I will pass 4. See, I am not getting any squiggly here on line number 25. I am happily calling the function, call function, and it should be return result. Okay, return result call function and return result. I am passing 4. But here I am executing this. So what does this mean? What I am doing? I am doing 4 like this. This doesn't make any sense. So that's why it is giving squiggly on line number 22, because this t is not guaranteed to be a callable function. It could be an integer. It could be a boolean. What stops me? Nothing. So here I have to constrain this to be of type function. So I'll say extends a function. Now what does this extend? It extends a function that doesn't take any argument and it can return anything. So let me write a function, say for example, say hello. It doesn't take anything and it doesn't return anything, and I will pass say hello. Now this will work. Why this is working? Because this t extends a function that doesn't take any argument and it returns anything. So say for example, it can return number. So say for example 6, and I will say it returns a number. This is going to work. Of course this is going to work, right? Because that's the constant that I have added. Now can I pass true? No, because it will throw error because it expects a function. So I will say hello. Now what if there is a parameter here? So say item of type number. Now if you see, we are getting squiggly. Why? Because this expects a function that doesn't take any argument, but here it is taking one argument. So what I can say dot args of type any array. That means this can take any number of arguments. It could be 0 also. So now this won't throw any error if this argument list is 0, and if argument list is 1, then also it won't throw any error, and let it return this item. So what does this extend means? This extend means a function. Now if you see here, there is a any type. That means it can return anything. Now what if I want to pass the return type as a generic parameter? So we already have t. I'll pass u as another generic parameter, and this is what is going to be the return type. And since this is the return type, what I will do, this function is being called and being returned. So what this will return? This will return type u. And here let me call this as f. F stands for function, and r stands for return type. So r, this is fn is of type f, and this is going to return type r. Great. So what this mean? This function is going to return a type r. Now here what I have to do, I will say what is the generic type here? Generic type here is of type, say for example, let us take this say hello. So what this parameter is taking? This is taking one item of type number. So I will say arg0 of type number, and this is going to return number. And what will be the second r type? Number. So what is this generic argument here? So if you see, one is f, which is of type function. So this is the f parameter. So this f must be a function that takes one argument of type number and it returns a number type. Now say for example, I am saying it is going to return string type, and here I am saying string type. Now can I pass say hello? Why not? Why it is throwing this quickly? Because according to this generic parameter, it is returning string type. But if you say this hello, it is returning number type. So if I say string here, and if I say string here, now this will work. And what else I have to change? I have to change the parameter. So I'll change the parameter. Now this will work. So that means I can write generic that takes a particular function type of a particular set of argument and return type, and it will execute that on my behalf and return me the result. So if you see here, what is the result one? It is of type string. What if I say, for example, boolean, and it will return boolean. Now how I have to change this generic? So this argument is taking type boolean, and what this is returning? This is returning boolean, and here also I'll say boolean as the other generic parameter. Now what will be this say hello? Say hello result will be boolean. So this f has a constraint that it can take only function. And what is the function? It can take any number of argument, and it must return type r. R is being passed here as boolean. So this is the first generic parameter, that is a function of type one boolean argument and one boolean result, and this boolean we are passing it here, because if you see this r is this r and it returns this r. So boolean, so this function returns boolean, which is being passed as the second generic argument, and the same thing of type r is being returned, right? So this is a constraint in which I am saying it could be a function of any particular type. I can manipulate it accordingly. We have seen different types of constraint, right? It could be a literal constraint, it could be an object constraint, or it could be a function constraint. Now let us write a constraint in which the generic argument can take only of type class. This is important because this same fundamental concept we have used when we are writing class based decorator. So if you have not seen that video, feel free to watch that, because there we have discussed this in extreme detail. So let me write a function that will create an instance, and it takes a generic type, okay, and here I can say for example class type of type t, and what this will return? This will return new class type. So what does that mean? Whatever I am passing, it will get an instance of that and it will return me. So of course this is giving squiggly, right? Because TypeScript doesn't know if this t is a class type so that it can instantiate it. And what I can do, I can say for example class user, okay, and it has a function get user, and this return this dot return, say for example Bob. Now I can call this function, I'll say const instance equals to create instance, and I can pass user. And let me correct this spelling, or it's possible that I can call this with 5. So this create instance on line 41 is not throwing error. I can pass anything, but who is throwing error? On line number 32 we are getting error, because this t could be anything. Right? Now my first target is to restrict it to a type of class. I can send only class, nothing else. So how can I do that? So I'll say it extends something. Now what is that? So how can I define a class? So I can say new, because I instantiate class with this new keyword, and it is of type instance type of t, and this is the constructor. So constructor can also take some parameters, so I'll say any. So what does this mean? Now this means it can take anything that has this new instantiable keyword or this constructor type. And what this is going to return? This is going to return instance type of t, right? Now this constant means a class. It can take only class, not the object of the class, not a function, not a boolean type or integer type or object type, but only a class. So if you see, we are getting squiggly here in 5. So what if I pass this user? Now this will work. Now it is not throwing any error, and if you see this instance, it is of type user. And how can I say it is of type user? I can say instance dot, if you see, I am getting the TypeScript or the VS Code suggestion get user, where this is coming from here, right? Now say for example I have a class person, okay, and say get person, and say for example return false. This is returning false. So if I say create instance and pass person, if you see now what suggestion I will get, I will say get person and if I store it in a variable, say for example person type. Okay, so here what will be the person type? It is going to be of type boolean, because this create instance exactly knows what it is taking as an argument and what it is returning as a return type. So here I can explicitly say person, and if I want I can pass the constructor, write a constructor, and if you see here it should be any of array, not simple any, so that it can take 1 or 0 arguments or more than 1 arguments, and it can be 0 also. So this is the example of constraint of class type. So that means I'm restricting it to be only of a class. Now let us check the next example. So here, say for example I have a type of course, and what is the type of course? So this is going to be of type, say for example I have a property called as course name of string and duration of type number. So this is my course, and now what I will do, I will say const course of type course, and I will say course name equals to TypeScript and duration say 4 months or 4 weeks, whatever it is. Then what I want to do, I want to write a function. I want to write a function, say get property, and this is going to take key of type, not sure, we will add it, and this is going to return something. We don't know what this is going to return. And what I am trying to say, I am saying return, say for example course of type key. So here in get property I should be able to pass course name, so it will return TypeScript. I should be able to pass duration, so it should return me 4. That is what I want to achieve. So I want to say course name equals to get property, and I want to pass course name. So here I am expecting it should return me the course name property. It should return the course name property value. So here I am expecting TypeScript. That is what I want to achieve. Now here I want to pass it as a generic constraint. So I will say T. So key of type T, and here if you still see we are getting error, so I will pass this T as the generic argument, right? Now if you see we are still getting error. Why? Because there is a possibility that instead of course name and duration I might send, say for example ID, get me course ID. But is there a course ID? Do we have ID property in course? No, it has only course name and duration. But what stops me from passing ID? Nothing. So now I have to restrict it. Restrict it to what? Restrict it to either course or duration, so that I should not be able to pass ID. Otherwise how TypeScript will know what property it has to return? So what I can say, so I will say T extends what? Key of course. Now what does this mean? What are the key of type course? It is course name and duration. So this T can be only course name and duration. It cannot be anything else. So if you see here ID, I am getting squiggly. Why? Because this ID is not key of course. What is the key of course? It is either course name or duration. Now if you see, course name is of type string. Now what if I pass duration? Duration is of type number. So let me also rename this duration, right? So this is going to be of type number. How does this know what data type it is? Because it clearly knows that T, which is either duration or course duration, is key of codes, right? It cannot be anything else. It cannot be of ID, or it cannot be of any other type. So if I say duration, it knows it is a key of course and duration is of type number. So it return type is number and it will return 4 in this case, right? That is not important, but what is important here is what data type it is returning. So this is going to be of type number, right? Now say for example there is a type data and it has a info of type string. Now this get property is only working with course. Can I write one more generic argument? Can I pass one more generic argument to this so that it can work with any data type or any object type or any type? So here I am saying data and it has a property of info, and I will say const data equals to, and this is going to be of type data, and say info, and let me say some information, and here it is not date, it is data. Okay, now here this get property, can I pass info? No. Why not? Because info doesn't exist on course, because I am here hard coding it as course. So here instead of hard coding it as course, let me make it as another generic parameter u, and I will pass this u. Now what does this mean? This means t extends key of u and there is a u. So here what I have to do? I have to pass, what I have to pass? I have to pass info, and also I have to pass what data type this property is going to come from. So I will say data. Right. Now if you see, I am not getting any squiggly then, but I am getting squiggly on line number 59 because I am saying it is course. So here I will say object of type u, and here I have to say object of key. So then it is giving squiggly. Why? Because it expects another parameter. I will say data. So here I am passing info and data, and I am trying to get the property out of that data. Right? So here I will say info data. Right? Now what if I want to use this with this old course? So I will say const course duration equals to get property. Now what property I want to get? I want to get, say for example, course name. From where? From the type of course. Okay. And here I will say course name. So if you see, I am getting what? I am getting suggestion. So as soon as I do this, it is saying course name. And from what? From course. So if you see this duration, so spelling I will fix this one. So if you see, what is the type? String, because I am saying course name. So I will just change this name instead of course duration to course name. So it is string. Now if I want to get duration, what I have to do? I have to take the duration property from course, and if you see, I am getting squiggly. So what value it is expecting? Is expecting duration property, right? Duration from course. If I do this, what value I will get? I will get course duration as number. So now see how powerful this generics has become. So with one function I can constrain it to a particular type, and I am getting that particular suggestion. Not only the suggestion, but also I am getting return type of that particular type. So if it is saying duration, I am getting number. If it is saying course, I am getting string. So if you see, if you properly use generics, then we can get type safety guarantee here, and we can pass different data type based on our needs. Of course, this might look silly because these are made up examples, but in real world, if you restrict this kind of data type, you will not only get the proper return type, but also type safety in your function arguments that you are sending. Then next example. So here I want to say function, and say for example, I want to say display size, and it takes a property of t, and size of type t, and it is doing something with the function. That is not important. Now what is important here is this type t can be of anything now, but this size I want to restrict it to small, medium and large, nothing more other than that. So I will say extends small or medium or large. Right now when I call this function display size, here I am getting suggestion. What suggestion I am getting? Large, medium and small, right? If I try to pass XL or extra large, is it going to allow? No. Why it will not allow? Because this parameter which is of type t extends literal type of small, medium and large, nothing else. So you can only pass small, medium and large. You cannot pass anything else. You cannot pass true, right? You cannot pass 4, or you cannot pass, say for example, this class person. You cannot pass person here. You can only pass small, medium and large. So this is an example of constraining to few literal types. Say for example, it could be a direction. So I can say east, west, north, south. Only you can send east, west, north, south. You cannot send anything else. So this is example of extending literal types. Then next example that we will check is implements a particular interface. That means we have already seen that it takes a type of class. Now what I want to do is I want to write a function that takes a object of a class that implements a particular type of interface. This might be confusing, so let us check with a code example. So here I have a interface has get name, and here I am passing get name as a function and returns a string. Then what I want to do, I want to create a function that print name of on generic type t, and it will take an object of type t, and of course it is going to return a string. Then return object dot. I don't know what is the dot here, but eventually I want to use get name like this. It is throwing error. I am not getting any TypeScript suggestion. That means what I have to do, this t, what is this t actually? This is a object of a class. So here I will write a class, say for example animal. Okay, animal, and here what I want to do, say for example dog equals to new animal. Here I want to pass, or in this print name I want to pass this dog, but this dog doesn't have a property get name, because if you see I am getting squiggly on line number 75, not on line number 81. That means nothing stops me from passing dog as a object type of animal to print name, but this animal doesn't have the get name function implemented. So that means it will immediately throw error where on line number 75, because this dog is of type t dog, object of type animal. So t is animal here and dog is a object of type animal, but it doesn't have this get name method implemented, but I have this has get name interface, right? So what if I say implements has get name? Now if you see animal is incorrectly implemented, so I'll say quick fix and get name. Now this animal has a get name and I am passing dog which is of type animal, but still it is throwing error because this t doesn't know that it is of type animal that implements has get name. So here what I can say, extends, simple, extends has get name. So any class that implements has get name interface, its object will be accepted as t, otherwise not, right? That means I cannot pass any random value. It must implement that interface and it must implement that method, of course, because once you implement, it will force you to implement this method, otherwise it will throw compilation error. So here what I am saying, this T must extend this has get name interface. So this is what this animal is doing, and all the object of this type animal will be accepted in this print name. So what we have done, we have restricted it to a class objects that implements a particular interface. So this is all about generic constraint. Generic itself is in a powerful feature, and on top of that, if you use generic constraint, it even becomes more powerful. So I really hope that you were able to visualize the power of generics and the power that it gives us to the TypeScript developer to write libraries and other utility function that uses generics, and also I hope you learned how to use the generic method. So with this I'm concluding the generics topic, and if you have any suggestion, any comment, feel free to put it in the comment section. Do like, share and subscribe to the channel, because I keep bringing this kind of content, and I will see you in the next video.